stuff, and I want to learn a lot about it. Nkululeko, sir, here's your introduction. So today we have Nkululeko Radebe. I hope I pronounced the surname right. He will be educating us and bringing us up to speed with the DevOps realm in technology. Nkululeko, sir, would you like to say anything in addition to what I have?
No, you said everything.
All right,
That's what.
lovely. So we are all excited to hear what you have to give to us today, and I'll be waiting with questions at the end.
All right, cool,
All to
cool,
you.
cool. Guys, I don't mind having us having an interactive discussion, right? I don't want to preach and then you guys you don't have any questions. So as I'm going, feel free to stop me and maybe ask questions because maybe you might forget, what you wanted to ask. All right, cool. I will share my screen just now, but I wanted to quickly take you just to give you an overview of, my background and what I do. So I am originally from the Val, and then I went to the Northwest University, studied IT there, and then I also completed uh, an honors in computer science, and then I started working, and then later on I did, you know, because we don't want to be in IT forever, right? So I did another course just to get exposure to leadership. So yeah, that's me. So in terms of work, I started off at a company called Avantage. They do airtime lending there. So I joined as a junior DevOps engineer, and then I went on to join FNB. And then after FNB, I joined ShopRite for a little bit of time, went to Momentum, then came back to FNB again. So that's where I'm at the moment. So in terms of DevOps, I've been doing that for quite some time now. Cool. And now that that is out of the way, I'm going to share my screen quickly just to take you guys, through what DevOps is or what I think it is. I think a lot of people maybe might have like, a different kind of view on what DevOps is, but hopefully I answer some of your questions from our session today. So DevOps, so you'll notice that other people are called DevOps engineers, others are called DevOps practitioners, others are called DevOps specialists, right? So DevOps on its own is not really a title, it's just a way of doing things, right? So, and it's a way of thinking. So it's an agile way of doing things. It's an agile methodology, to be honest. So it's basically before DevOps, we used to have developers that would write the code and then give it to your IT operations team and to say, okay, cool, I've developed this. Now you can deploy it, or maybe you can implement this at FNB, right, or any other company. So think of it that way, to say that you have, even if it's an app idea, you're like, okay, I've written code. Now it's time for people to have access to your code. You would then have a team that is responsible to actually implement that for you and basically to monitor it, right? But that is two teams, and often when there's issues, the operations guys are going to be like, we're not sure what's wrong with your code, come and fix it. And the developers are going to be like, it's not our code, it's your infrastructure, right? So that's where DevOps came about, to sort of bridge the two, right? To help and deliver your software much faster and efficiently. So meaning that you sort of automate from start to finish of when your when your application or code or service was built down to when it's deployed, and then you try to monitor that, right? So if I don't know if you guys have any questions there, but I'll move on to the next one here. So at DevOps, there's what we call DevOps.
I
Okay,
think
cool.
there's somebody who has their hand raised.
Coco, Poshoko, yeah, you can go.
Yeah, so just DevOps, like from
Yeah,
what you've explained, right? How
yeah.
exactly do they like do all this automation? What are the tools involved, or is that something you're going to explain later?
Yeah, no, we'll cover that as well. So it's
Okay.
actually on my side, right? So we have a life cycle. Remember what I said about Agile? If you guys maybe are aware of Agile, it's the idea is basically instead of having your water flow kind of way to say we're going to plan a project, start the project, and then build, and then hand over. And so Agile doesn't do that. With Agile, what we're trying to achieve is that we basically have an iterative or a sort of like a cycle to say, okay, we want this feature, we build this feature, we get feedback. Is this what we wanted? No. Okay, let's change it. So it's more like a cycle, right? So with DevOps, we have exactly the same there. So we have the planning stage. So you guys, I think most of you, if some of you are working already, you might know this. But if maybe you guys are, some of you guys are still going to be exposed to it, you will come across tools such as Jira, right? Jira is used a lot for planning and also to break down your tasks to say, okay, cool. We want to build a messaging, we want to build a certain feature. Let's take, for example, on an app to say we want to introduce a feature whereby people can like message directly, right? So instead of putting just uh, that functionality on a high level, you basically break it down into smaller components to say, okay, cool. We need to enable this integration for us to be able to talk to each other. There needs to be a database link where how are we going to do the caching and all of that. All of those discussions are done on Jira, and then they are planned out on Jira, and then from the Jira part of it, that's where developers get assigned to say, okay, cool. This is what you are going to be responsible for. This is what you are supposed to achieve. They normally cross them sprints, right? Then it comes to code. So with code, so planning and code, that's where you have your DevOps engineers, but they are more on the sideline. So they we basically part of those discussions, but not actively involved, right? So you normally have your project managers, your software developers, your architects. They are all around planning. And then when it comes to code, that's normally where the developers are. Right? To say, okay, now we can build this feature. We have all the details that we need and everything that we need. We basically have it. Now we can start coding, right? And then you code, you're done. So under code, this is where you have all your programming languages, whether it's Java, C Sharp, Python, they are sitting under code, right? Then the next step, which is the build phase, that's when that's where DevOps actually start to kick in, right? So previously, I think even at school, you guys would notice that when you are given a project, you have to code, and then you normally do like a manual build to say, okay, I'm going to build it and then I'm going to execute it, try to see what it does, right? So what DevOps does is we basically automate that process, meaning that once you're done, you push your stuff to Git. Let's say you're using GitLab, right? You'll be like, okay, I'm going to push my stuff to GitLab or GitHub. As soon as that is pushed, we write pipelines, so we'll come to it. So they are called CI/CD pipelines, whereby we're going to build that application. It's going to go through a round of tests. After testing, that is also other tools that are integrated over there. That's where you have your JMeter, or you can use your JUnit or Jacoco, any tool that the developer is using, or as a team you decide to use to test your code, you would do it. If there's time, I'll maybe try to show you guys this on with a real life example of what's happened. And then after the testing, we then do a release to say, okay, now we comfortable, this is ready to go to production. So we don't just push stuff from test straight into production. They would go to being released. So now when we have a release, it now goes to environments that are called staging environments or QA environments. Well, test also includes QA, but you would have other environments whereby it's basically pre-production environment to just do all the necessary tests to say, okay, no, if we push this code as it is, it won't affect anything on production. And the feature that we expecting, that was included through the planning all the way to release, will be there. Then comes deploying. We will actually deploy this. And then operating, that is now just to ensure that all the integration that your application needs, or your website or your mobile application, it's able to access all of the services that it needs. And you don't just deploy an application and just let it be. We basically then have to monitor your application. So there's different tools that are used inside monitoring. You'll often hear of Grafana, App Dynamics, Datadog. There's a lot of monitoring tools that can be used. Actually, there is this slide that I put here just for you guys that are interested in the tools and what segment do they fall under within the DevOps lifecycle. For don't if you are interested in DevOps, don't think don't look at this slide and think, okay, crap, I need to know all of this. No, it's not like that. Let's take a question first from, I think, Poshoko. Is it
Yes,
Lebohang?
I just wanted
Oh,
to
yeah.
ask, in a slide with the cycle that you were showing us,
Yeah.
like after you built your code,
Yeah.
tested, where do what happened, like between after the build, where does these things that are built now, where do they go in that release phase? Do you take it straight from after the test straight into some sort of environment? Does it not get stored somewhere and marked as a release, like something that is new? You know how you have apps, before I can update, I'm notified on my phone that there's an update available.
Yeah. So I know that's
Is
a
is
brilliant
there
question. That's a good question. So actually, there is. I don't think. I don't think. I don't think there's. There's this whole. I don't know. Infinity sign shows everything, right? So what would then happen is that there are tools such as you guys might know them as Artifactory or your Nexus repo, whereby its job is to basically hold your artifacts. So let's say, for example, I'm going to use maybe a Spring Boot application, right? If you are building a Spring Boot application, which is Java, it's going to generate a file called a jar file, right? So now you want to make sure that you keep track of those jar files, whereby you can even version them, right? That's where you start to use tools that are called repository management tools, whereby you will store your code, you will store that artifact on that platform. Let's say we store your jar file on Artifactory. And then during release and deployment, we basically fetch them via a CI/CD pipeline, and then we deploy them, if that makes sense. So prior to Docker being introduced, you would do like a deployment whereby you copy your artifact into the server, right? But now with the introduction of Docker, I feel like I'm mixing things here. But inside Docker, there's something called Docker. So a Docker is more like a VM or a virtual machine that you create, but it's very lightweight. You basically package everything, and then you then can do a release. But it's the same logic to say all of your artifacts are sitting somewhere whereby you can fetch them during a deployment. I'm not sure if I'm answering your question.
Yes, satisfied. I have
All
another
right.
one from the Docker, but I'll ask it later.
All right, cool.
Yeah.
Let's take the other one. I don't know the name
Hello,
here.
my question is for the next slide.
Okay, cool. Let me go to that next slide. Yeah, cool.
Can you share these this specific slide, because I started in ops, but we still
Okay.
use like our ops is automated. So I'd say I use a lot of tools there, but there are some tools that I don't know. So I don't know
Yeah.
if I should screenshot or you're gonna share it to us.
No, I'll share with you guys. And also,
Okay.
I think, yeah, so I will share with this, right? But one thing that maybe I would like to maybe highlight, right, is for you not to try and learn everything that's over here, right? You always try to learn what makes sense for for that business, for your business processes. For example, you can have let's take for example what's trending now: AWS, Azure, and Google platforms, right? Most companies are going to AWS, but only to find that they didn't even have to go there, only because of it's a buzzword. So I think maybe also just make sure that you don't try to like explode your head trying to learn all of these things. Just
Yeah, I
take.
think with learning, like being in tech, like these technologies are just similar. Like different
Yeah,
companies will
absolutely.
tell you, yeah, they'll tell you, okay, we have this and we have that, but it's different names. Yeah, well, so I just wanted to
Absolutely.
know what other tools I may use. Let's say I know like you can use Terraform for like infrastructure provisioning in the cloud, but you can also use Ansible, you
Yes.
know. So yeah, I just wanted this slide. So maybe if some in my team they're asking for like innovation, and be like, okay, maybe we can try this. But okay,
Absolutely.
thanks.
No, I'm with you. Cool. Cool. Yeah, so this like I don't think even these tools are like enough here. So you can, when I look at these slides and looking at the tools that I've used, like I also get scared to say, okay, now I've used quite a lot of tools, but you will realize that you get to touch all of them, but without even realizing it. But don't try and learn them all at once. You'll just go crazy. All right, cool. So why does DevOps matter, right? Um, I think from what I've said as well, right? It makes things run much smoother, right? Imagine now you're a developer and you want to push your stuff onto like a development environment. You don't want to be always having to tell someone, please, can you copy this file for me, right? So with things such as CI/CD, everything is automated, and those changes go automatically. So, and it enables you to like get your stuff like tested much more quickly, and it also ensures that there's consistency around the environments. So, one thing that you guys will realize, I think you might maybe see this even at workplaces, that sometimes you find that dev environment or the QA environment is not the same as production environment. You have a code that's sitting on production, but it doesn't exist anywhere else, right? Or maybe you have a code that's sitting on QA and production, but it doesn't exist on the development environment. So by using a CI/CD, you basically ensure that all of the environments are the same, meaning that if it's working on dev, it should work on QA, UAT up until production, because the environments are consistent throughout, right? And then also with the human error, I mean, we do make errors. So if you have like a CI/CD, then you know that, things are automated. So, and then when it comes to the CI/CD part of it, right? So CI means continuous integration, right? That is the building and the testing of the code, meaning that you're basically building your code, you're automating the building and the testing part of your code, right? So in some companies or in some of the tools, you'll find that it's actually a CI tool rather than a CI/CD tool. Like for example, with Jenkins actually came about being a CI tool that was used to build applications, and then it would then just do like a copy to drop it, let's say for example, to drop it somewhere, right? It's only in the later stage whereby they started to integrate the CD tool, meaning so that it can also do deployments, right? So you will come across all of that. So and then so for the CD part of it is continuous delivery or deployments, right? So difference between delivery and deployment is that sometimes you especially environments whereby, let's say for example, you don't want to automate the deployment of an application necessarily. We basically want to say, okay, we've built your code, and then you basically take that artifact and drop it on the server. Someone still needs to come on the server and maybe copy it to the right folder. Maybe it might be because the environment is too sensitive. Let's say for example, uh, you don't want to like maybe automate, like necessarily automate everything, whereby you're going to be deploying an application that affects people's money, right? Maybe you want, someone to actually do the copying. So that would be CI/CD as well, but with continuous delivery. But with deployment is whereby as soon as we hit that button, that change is deployed and it's live, right? So that's the major difference between, it's not a difference, but sort of, the logic behind. And then with the automation, like I said, it'll make your life easier. You with DevOps, what I've found, what I've come to realize is that I do most of the hard work when things start. As time goes, you like things start to really chill. Like you no longer get like those calls that you used to get, like to say, can you help us with this? And DevOps, remember, it needs to be a more of research and development rather than, like an active role whereby you need to do a similar thing every day. So you basically go out and research to say, okay, cool. What's the latest that we can apply to basically smoothen our processes? And then you come and apply it rather than doing the same thing over and over again. Right. So that's why automation is at the key or at the center of DevOps. And then we have a factor that normally I think you guys will also realize it when you start to get into like for those that are going to get into DevOps, or maybe just around the operation side of it, is security plays a big role. Because I know with developers, because we like, let's just build the functionality, we'll worry about the security after, right? So security is always something like we like, okay, no, we'll leave it for last instead of doing it, from the initial step. So they came up also the concept of DevSecOps, meaning that we integrate security within DevOps, to meaning that every step of our pipeline or our process actually gets tested. Like, for example, when you build code, it would go via maybe SonarQube, right? Whereby we're going to test. Does does your application actually meet all the international standards and it doesn't have any vulnerabilities? And then if it passes that, and then you're building like a Docker image, we also scan that Docker image to say, look, you might be using a dependency that is vulnerable to hacking. This is a solution. This is a version that's working. You'll be using tools such as Trivy to say, okay, this version is no longer up to speed. Like, we use this version so that you patch that whole security. So that portion of 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 DevOps or DevSecOps is basically just to integrate security within the automation, because it's nice when things are automated, but do you really want to automate things that are not that safe? Right. So that's why the sec part of it was also introduced. Poshoko?
Yes, so I just wanted to ask, like coming from a developer's perspective, when these security scans go about, what exactly do they look for? I understand like the versions, because certain things can be marked as deprecated and all of that, but then what other stuff are they actually looking for, especially in things like Docker containers, besides the versions?
All right, cool. So if you're working with containers, right, let's start with Docker, right? You would basically with Docker, you ideally don't want your application to run as a root user on on your Docker, right? So it would basically be looking to check that, does your application, when it looks at, let's say it looks at your Docker file, there's something called Docker file for those that maybe don't know about it. It's basically blueprints of your Docker image to say, okay, I want I want this application to be installed. I want this to be configured. So with those tools such as Trivy, what it will do, it will basically scan that Docker image also to say, look, you basically copying the whole directory instead of copying your artifact. That might not be safe, because then your code, in a case whereby people can get access to your Docker image, they are going to get access to your code, right? So rather copy the artifacts. It will basically look at that, and then with a tool such as SonarQube, whereby it's looking at your code, it's going to basically say, okay, cool, you are using an if statement with things such as if this, if, so you basically have if if this, and then else if. So it'll do suggestions such as, just use a case, so that at least you handle this much better. And remember, for those that are coming from a data structures side of it, there's quite a lot that happens at the back end, right, of a function that you are using. So it shows you those kind of vulnerabilities, things such as, don't use maybe a regex expression to try and detect this. Maybe use a certain function that is available. So it also improves your code. At the same time, it also improving you as a developer, to say you get used to writing code that is, sort of in the international standards, and is like,
Your
can you guys
voice
hear
cut
me? I think I
out.
lost you first.
Yes, we can now.
Okay, cool. Is it fine now? All right, cool. Okay, cool. So coming to infrastructure as code, right? You guys will hear a lot of it. People saying infrastructure as code. In simpler terms, when it comes to infrastructure as code, we basically, I always like to tell. Yeah, sure.
Yeah, I just want to ask a question on top of what he asked. He asked from a developer's perspective, right? And then let's say coming from ops, where you deal like with servers and like firewalls, like all this networking principles. How does that look in the DevOps space? Do you guys still take care of that side, or you just worried about the deployment and that integration with the code?
No. So on our side, what we're looking for, so think of it, that's a very much good question, right? So developers, they measure themselves with how many features did they release that are on production, right? With DevOps, we measure ourselves on our services up and running, and are they always available, right? So meaning that with your code, from your point of view, you're looking at how can I get things in, and the developer and the DevOps are like, we want you to get your stuff in, but we want you to get your stuff in that won't break our KPIs, meaning that we don't want to be losing our bonuses because we basically push the code that's breaking, right? So it's basically striking that balance. And in terms of who's responsible for what, the DevOps would ideally be the ones that are actually uh, creating or deploying the applications such as your SonarQube, and then basically integrating with CI/CD. So DevOps are in a way creating a platform that enables the developers to do their work, right? And to also create a platform whereby we can monitor operations so that we can, you know, give feedback to the business, or maybe give business a view of what's happening in production. I'm not sure if I'm answering you, or maybe I'm just digressing.
Yeah, that makes sense. Thank you.
All right, cool. Then with infrastructure as code, right? So remember when I kept on saying we used to have the IT ops guys. So the IT ops guys would basically look at the infrastructure and deploy those applications. The developer only worries about code, meaning that if a server is unavailable, the operations guys are hard at work trying to fix stuff, right? But as time went by, we moved on from physical VMs to virtual machines. Now we move into like virtual machines that are sitting on cloud, or even other, they're called serverless, meaning that it's just an application that's running over there, right? So with things such as your AWS, your Azure, even on-prem, right? Think of it this way. You want to create, like, let's say, for example, we're creating a new project and we want 50 servers, right? And we have to install things such as your Docker, we have to install your Kubernetes, we have to install all these other tools, configure all of them, right? First of all, no one wants to be provisioning 50 servers, like one by one, and configuring them. It's going to take you a very long time, and you're probably going to hate your job, right? Just like how people hated their job. You'll notice some of the old guys in IT, they get frustrated really easily because they've been around and they've seen tech come and go, and they like get frustrated as soon as you want to introduce something new, right? So infrastructure as code was actually introduced to simplify things. So meaning that you basically write a script to say, I'm provisioning one server that has Ubuntu installed, that has Docker installed, that connects to this server and all of that. And you basically have it as a code. And then as soon as you click on apply, it goes and does the provisioning for you, meaning that if you're going to be provisioning 50 servers, you can provision them all at once by running one command on Terraform, and then it basically provision all of those servers for you and basically configure them, and then you are able to start using them immediately. And when you have a disaster recovery, when you have a disaster, let's say for example, your servers for some reason someone just decided that because they were fired or they are resigning, they just click on delete and then they deleted all of their servers. You can basically then rerun your Terraform script and basically re-provision everything that you had before, right? So that's at the that is at the center of things when it comes to Terraform and infrastructure as code. So Terraform is an infrastructure as a code, while Ansible is actually considered as a configuration management tool, meaning that it allows you to install applications, but it can do the provisioning, but it's not as optimal as Terraform would be. So that's the main difference. But it basically helps you to basically achieve infrastructure as code. Um, Question?
Yes, I just want to know, how do you upskill on Terraform?
Your mic, your mic is a bit soft. I'm not hearing you
Can
properly.
you hear me now? Hello?
Yeah, I can. Yeah, I can.
Okay. How do you upskill yourself with using Terraform and Ansible? I know, Hori, with the Ansible, you write your own playbooks, right? And then with Terraform, you do the Terraform configuration. But with Terraform, it makes sense if you use things like AWS. But I'm just coming from a side of a student. AWS is expensive, you know. So how do you like build a portfolio? And obviously, building a portfolio, you should show that it actually works, you know.
Absolutely.
Yeah.
Uh. So with Terraform, remember Terraform, you can upscale, and but I like your question around how do you upscale yourself with your AWSs, your Terraform, but you don't have the money to basically run this. So you guys will be aware that there is AWS, Azure, and Google platform. They have what is called free tiers, right? Whereby they give you a certain allowance which is for free. It's a sort of like a virtual money for you to basically provision things on AWS and then destroy them without paying anything, meaning that you use those credits before they start billing you, meaning that you can you can put you can put your card details, those that card that has 1 rand 50 in it. You can basically put that on AWS on the account when you're creating it, and then basically it won't cost you anything. You can use those AWS those credits up until they run out. When they run out, you can always spin up, create a new account, but with a different, let's say, different email, and then basically play around with it. So you don't have to pay for them upfront. However, there are instances, or maybe there are some of the features or services that are not available on the free tier, meaning that you can't use them. So unfortunately for those ones, you might just have to wait for until you are provisioning them for a company, or if you have money to do so. But you can always use the free credits that are available for you guys to just play around with these things. And also when you go to like an interview and you are being questioned around Terraform, they won't interview you like, you're a wizard of AWS. They basically just want to see if you understand the basic principles and the logic behind, because like no one knows everything around AWS and no one knows around all the commands that exist within Linux, but you ideally want to see if someone has an idea of what's happening, so that it's the transitioning and also for them to join the team is going to be much quicker than someone that has to basically start from scratch. So the basics are what's important, really. Questions? All right, cool. I'm almost done. So with DevOps, really, I would say if you want to get into DevOps, start by learning Linux and scripting. That's the most important one. If you know coding, that's good, and you're probably going to be using coding somewhere, and especially when you're helping the developers, right? It's much more easier if that coding experience. But if you want to get into DevOps, start learning Linux. And I'm not saying go and memorize all the Linux commands that exist out there. No, know the basics of, okay, how do I change directories? Okay, how do I check the IP or VM? All of those basics will actually help you to like, sort of get into Linux. And then with Git, while you're learning everything, especially around scripting, just maybe use Git to say, okay, I'm going to save my stuff on Git, and learn to type those Git and all of this. I normally use cheat sheets. So you just say Git cheat sheet. It'll give you all the commands that you can use with it, and simplify all of these commands. I mean, I'm not a fan of memorizing commands. Just know the basic idea behind, and then you'll be fine. And then check out things such as Docker. Docker is the it thing now. If you are running away from learning Docker, I would say it's not a good idea. As a developer or as a DevOps engineer or anything around, even as a data engineer, I would say start to learn Docker, because then you're able to understand the network layer of how things connect in the background. Your Jenkins and your GitLab and GitHub as well. So GitLab and GitHub, they have CI/CD tools that they embedded on them, meaning that you don't have to use multiple teams to a CI/CD pipeline. You can basically store your code sitting on GitLab, and you can create your on GitLab, and you can store images on GitLab as well. Before I go to Kubernetes, Poshoko.
Thank you, sir. I've read lots of times that in DevOps you also need to have networking knowledge. How strong should that networking knowledge be? Like, is there a way that you can gauge, well, okay, this is how much? I mean, obviously not as much as a network security person, but then like
absolutely.
how
Yeah, so that's what I was saying. So you're absolutely correct there. Whoever was telling you, or wherever you were reading that, is very much correct. Because you tend to have you tend to have quite a lot of things connecting in the background. Like it gets really, really complex. I mean, I don't want to scare people that want to get into DevOps, but with the connectivity, it really gets complicated. Like as you go up, especially when you reach Kubernetes, whereby you now need to know okay, these Docker images or these pods on Kubernetes can't basically talk to a certain to. So if I were to explain the networking within DevOps, basically take this, guys. It's not that really complex. So well, when you're explaining, it's not that complex, but when you are there, it's really hard. So you basically have, let's say you have a server, and let's call this server one, right? That's your server, right? And then you like, okay, and then it has an IP. Let's call this IP. Let's say it has 19C 192.68.0.1. Oh, it can't be. Let's say it's this, right? And then you basically have this kind of layout, right? And you like, okay, we want to use Docker, right? Docker is going to come with its own network, meaning that now let's say you have Docker here, that's sitting here. Docker, that's the engine, that's the Docker engine that's running here. And then you have your container. Let's say we have a container that we say it's application. Let's say application one. There's application one. And then it has its own IP. So that's what's going to complicate things for you. It's going to have its own IP that it's coming with. And then you have another one that's sitting here. It's an application two. Application two, right? And you have someone whereby these are the end users and they want to access this application. Unfortunately, they can't just say, okay, I want to access this application directly. They can't do that because at this network level, this guy can only see 192.168. So it can only go up until here at this level. And it's trying to hit, let's say, for example, it's trying to access, I'm trying to access 192.168.0.5, and I'm trying to access port 443, which is the HTTPS, right? And I'm trying to access my application. I can only come here, but this traffic only hits here, and when it hits here, it's like we're not sure what service you're trying to hit. So you basically then have to use things such as your Docker networking to basically create a link to say, okay, I'm going to expose this port here to come here and be able to be reached by this. So you then have to create like port mappings and all of that. I'm just wary of time. If we still had time, I would actually show you guys in a real life example, even with Kubernetes, on actually how it looks like. But the networking side of it, guys, it's something that you learn. I would say actually thinking about it now, I would actually put it over here. I would networking as well to just understand how things connect. It's not really, it might be difficult when you start, but as time goes, you'll understand it because the very same networking that you're going to learn, you're going to need it for AWS, Azure, or Google Cloud. Actually, you're going to need it all the way until within your DevOps career. So, and then, but I would say just be curious, be hungry to learn. Don't try to overwhelm yourself with, with quite a lot of details. If you guys go to like LinkedIn, actually had it open just to show you guys. If you go to and you just say maybe DevOps, you'll see like there's at the current moment like DevOps is getting um quite a lot of they basically require a lot of people, basically. I would say that because companies are trying to transition into that. But if you go to the requirements, you'll notice that they're always talking about CI/CD pipeline. Either you've used Jenkins or Azure, Kubernetes, GitHub, but you will see most of these are sort of repeating throughout. If I go to this one, it's basically going to say the same things, just CI/CD, AWS, or it's basically like a repeating and then before I go on, a question.
Yes. My question is, which certs do you have? I think I joined late. If you already answered that, can you hear me?
What certificates?
Yes.
Yeah, no, I can hear you. No, I'm not a fan of certificates, to be honest with you. I try. The kind of encourage people to go that route. I would strongly encourage it, right? Especially when you want to get into DevOps. But what we've noticed with the certificates is that we tend to hire people to say that do they have a certificate for AWS, right? You and I both know that you can like learn something and then basically write your test and be done with it and forget everything, right? Versus someone that has like knowledge about that, they've played around with it. So I think certificates are like a good idea. Actually, I encourage even my younger brothers, because they want to get into IT from electrical engineering kind of background, to go into IT. In that situation, I would strongly advise to do a certificate. It's sort of like it sort of becomes your voice, so that when people are looking at your CV, they're like, okay, this is someone that knows their stuff from an HR point of view. But don't just do the certificate, actually do the actual learning, because the certificate is going to be there for you and for people to know that you have it. But just make sure that you understand the basic principles and how things actually work, because yeah, it gets rough. And I
Yeah.
think in a way, sometimes the certificate actually can to your disadvantage. What do I mean by that? Sometimes these companies are like, when you join, because they saw that you have a certificate in AWS, and let's say it's a DevOps certification, they already having expectations of you that, okay, she probably knows this stuff, right? Versus someone, maybe they're like, okay, no, I don't have a certificate as yet, but I've already played around with this and this and this. Then they basically give you like, sort of take things like a bit easier for you to say, okay, no, let's wait for her to transition and all of that.
But
But
which ones do you have?
which ones do I have? I only have Linux and Kubernetes, Kubernetes administrator. They call it CKA. So check out CKA.
No. And the Linux
With
one, which one is?
AWS,
Is it the CompTIA one or Red
no,
Hat?
no, it was a basic. It's a basic one that I did at the back in the days. It wasn't
Okay.
a Red Hat. Yeah, but the most important one that I think I've gotten myself is the certified Kubernetes administrator. That's the one whereby it allows you to create your own Kubernetes cluster and all of those things. Basically, they
Thank you.
teach you they teach you all of that. So yeah, that's it. Yeah, but it's not fun doing that thing. Then yeah, I think I'm done, guys. So this is basically, my final advice. I mean, DevOps, it is exciting, but it does get challenging. Some of the disadvantages of it is Most of the time you'll be required maybe to be on standby, whereby if things go bad, they basically have, maybe the first call or second call. Then if you're on the first call, then if we get an alert, you basically then have to respond to it and make sure that everything is okay. If they are not, you have to fix them. So if you guys are 5, you may be taking turns every week to say, okay, this is the person that's on standby this weekend, and so on and so forth. Questions? I think it's
Yes, sir. So I just wanted to ask. I see you said that it's not nice being there or something like that, right? How? Sorry, I
Yeah.
just lost my train quickly. When it comes to like your daily processes, you know how that whole CI and then CD. How often do those like fail when you guys are at like a corporate level or at a corporate setting? Because with us, the GKSS UNISA and stuff like that, we're still practicing all this stuff, and we get so many emails from like our CI pipelines failing.
Yeah. So it depends on how like you guys are like have your stuff. So and most of the time it's developers that are breaking their stuff, but it has nothing to do with DevOps. Remember, when you create a pipeline, you sort of create like we sort of create a car, and then how you drive it's up to you. If you crash it, it's all on you. But when a CI fails, it's it's probably what you guys have to check on, why is it breaking? You know, if you guys can give me a sec, I'm going to stop sharing my screen. I'm going to show you like what for you guys. But let me just another question. Um, okay.
Oh yes, you said something about being on standby. So I'm already on ops, and this week I'm going to be on standby. So I'm also interested in DevOps. Ne? And previously you said you worked at
Yeah.
like companies and so forth. So my question is like, because I thought DevOps wouldn't have standby, because I'm running away from standby. So is it company specific? Like, okay, at this company you would find the standby, but at another company there's no standby. Oh, there's like it's ops. Obviously, there's going to be standby. So that's my question. I don't know if you heard me.
So like let's come to that, right? So it depends. Okay. No, I got you. So it depends on the size of the company, right? If you guys are a big team, that's where you start to get your site reliability engineers. Site reliability engineers will be doing most of the getting of the alerts, meaning that things go bad. They are the first ones to investigate, and you would, and then like I said, depending on the size of your team, you might also have the guys such as your platform engineers, whereby the platform engineers are basically responsible for creating the platform, meaning that remember when the DevOps engineer created a platform, then the environment using infrastructure as code, and then they also monitor and be on standby. As the team grows, those DevOps, the, those responsibilities are then shared to say, okay, within the DevOps space, the platform engineers are doing the provision of the platforms, making sure that things can, deployed on the platform, and then you then get your site reliability engineers which come in on the monitoring part of things to say, okay, we're going to monitor and plan around those, right? So their responsibilities your responsibilities would vary based on the size of your team, right? The bigger your team is, the less likely you're going to get more responsibilities. But the smaller your team and you're DevOps engineers, you better brace yourselves because you're going to get like quite a lot of responsibilities. So that's that's basically how normally it is. So less guys, it might mean more money for you, but there's more work for you at the same time. And then the more the guys, the less money that you can make probably, because remember, when you're on standby, you get like, you can claim all of these things, but you also miss out on your weekends sometimes, especially when things are like breaking bad.
Okay, thank you so much.
I'm
It
not sure
makes
if
sense.
I covered you.
Yeah, you did.
All right. Hey, Pati, I know we are together on the standby. No one likes that, eh?
It's not nice. Kurun Mogiling, I'm like, I'm not looking forward to this. I'm looking forward to that next week. Yeah, I'll breathe. Thank you.
Yeah, no, yeah, you need to decide. You want money or you want sleep. So so it's always tricky, that one.
Standby is
But
nice when nothing
yeah, I
breaks.
want to show you guys this quick one before. Yes, and then you get the money. Yeah, then it's nice. Okay, I'm just going to share my screen with you guys quickly just to show you. Let's see. Can you guys see my screen?
No, not yet, sir.
Let me stop
Yes,
and
now
share.
we can.
Oh, crap. Okay.
There we go. Yes, now we can see
All
it.
right. Cool. So this is what I was talking about, guys. So you would basically, I'm going to try and reload this. Hopefully it works. Okay, let's take for example with Grafana. Hopefully this thing is.
Okay,
I'm
so
back here at home. So yeah.
Grafana is your monitoring service, correct?
Yes, that's correct.
Okay.
So for example, let's look at this one. So let's look at this cluster. Um, this is a this is a we call it black hole cluster, right? What it allows you is basically where we running our services, like your sonar tubes are here, right? You basically see things such as this, whereby you're able to monitor your cluster on how it's doing, how each node is doing, your services, how they're running. Um, you're also able to we have our applications basically running uh, inside the Kubernetes cluster. And what Kubernetes allows you to do is basically, if let's say, for example, something breaks, right? Let's take this. Let's say someone decided to say, okay, they are angry today and they're going to kill this. So if I was to kill this and destroy it, it's going to terminate and then spin up a new one, meaning that it always ensures that it's available. So these are the kind of things that you're going to work with. And the underlying layer, which is which is which is networking, it plays a huge role. So that's why I was telling you guys like that networking as well as Linux are at the center of how what's happening within the DevOps space. Yeah, Poshogo.
Sorry, I feel like I'm going to be a little behind. How different is Grafana from Rancher? There's a tool called Rancher that I've messed around with. It looks very similar, like with how you can see all the, I think they call them top or H tops, like your resource usage on each pod or stuff like that, correct?
Yeah, absolutely. So
How?
think of it this way. So actually, there are two different tools. So Rancher, so Rancher is actually there is a cluster. There is a so Rancher has its own flavor of Kubernetes. So for you guys, maybe know around Kubernetes. So Kubernetes is more like Linux, and then with Linux you can have Ubuntu, you can have CentOS, Red Hat,
Okay.
so on and so forth, right? So Rancher has its own flavor of Kubernetes, and then what it allows you to do is you can create it. It gives you it's more Rancher is mostly for people um, that are running Kubernetes on self-hosted servers, meaning on your traditional servers rather than on AWS. Although it can support it, but it's mostly for those, right? Then what it does is because AWS, Azure, and all of these, they already give you like platform for you to be able to visualize your clusters and all of that. Rancher did the similar thing, right? Whereby it integrates with your Grafanas, whereby it's able to embed Grafana within it for you to visualize your cluster. But basically, Rancher is a Kubernetes flavor. It's just another Kubernetes flavor of Kubernetes. So just think of it that way, because Azure has its own Kubernetes which is called AKS, which is Azure Kubernetes Service. AWS also has their own, whereby it's AWS EKS, which is Elastic Kubernetes Service. And then Google has its own. So think of it that way. And then Grafana, what it is just a visualization tool. You can visualize everything. You can connect it to a database and then basically just visualize the data that you have there to say, okay, I want to track how maybe my customers maybe a table or records on a table. So it's just a visualization tool. I hope I covered you there, Poshoko.
Yes, I
All right.
understood. Just
All
a
right.
just a quick question also.
Oh,
Grafana being like your basically just a monitoring tool. It does only the monitoring. If I'm going to host something, would I also need to find an environment to host Grafana? And is it open source?
so Grafana on its own is open source, right? So you have Grafana open source, and then it now has a cloud version. So it has a cloud offering whereby for exactly similar cases like yours, whereby someone is like, I don't want to provision a whole server just to run Grafana. Can't I run it? Can someone just run it for me? But I don't actually want to pay, right? So there is a a Grafana cloud which allows you to get to basically push a certain number of matrix and also a certain number of maybe logs or something like that before you can start paying. But it will basically be tough for you to reach those numbers, especially for a project whereby it's your own kind of project. It will be much difficult to reach those numbers. So you can just use that to simplify things for you. But if you want to maybe to do like hectic numbers whereby this is corporate and you guys want to save huge amounts of cost on monitoring, because monitoring tools are expensive, you can then just do like a self-hosted deployment of Grafana, and then basically run it that way. More questions, guys? Anyone? I guess you must feel free to ask any, even if you think it's like maybe a stupid question. There's no such thing as a stupid question. So feel free to
Sorry,
ask. Yeah.
I have another question. Like when it comes to the infrastructure as code part of things, how do
Yeah.
they do it enterprise level? Is there like a separate repository that holds
Yeah.
all the infrastructure as code, or like does each service that you guys are working on have its own folder where everything is, like everything related to this web app is going to be there, including its infrastructure as code?
So remember, quick answer is Git, right? Remember what I was saying that you need to start with Git. Remember, so with infrastructure as code, because over there you're dealing with your Terraform scripts and all of these things.
Mm.
So you want to store them on Git or on Git, meaning whatever Git repo you want to use, just make sure that you use Git. That way, whenever you make changes to Terraform, you save it on Git. But now there's a difference. So there is what we call Terraform state file,
Mm.
right? A state file is basically, you basically say, I want to create 5 servers that have this and this installed, right? It's going to say, okay, cool. Terraform is like, cool. I'm going to create all of these, and then it does, and then it creates them. But the next time you try to run that Terraform script, you don't want Terraform to be basically provisioning things again, right? You
Mm.
basically want Terraform to be like, dude, you already implemented all of these things. So there's nothing new to implement unless you are making some change. Then it should apply. But for Terraform to basically know of that, you need Terraform generate something called a state file, whereby
Mm.
a it's more like a Terraform's way of keeping track of the changes that it has done to an environment, so that the next time you try to run, it knows, okay, we study from here going forward.
Yes.
If that makes sense. So it's more
Yeah.
of Terraform's way of keeping track. So in that sense, you decide on how you want to save your state file. Terraform provides a platform whereby you can store your your state files on their environment, but up until a certain point before they will start charging you. Or you can be like, we actually maybe we want to back up our state file on something like a OneDrive or a Google Drive or
Mm.
somewhere. It can be saved anywhere, but you basically don't want to lose that, because if you lose that, you basically lost what was changed on your environment, and the next time you try to run Terraform is basically going to destroy and recreate everything that existed before it can do that.
Mm. Okay. And then, like, what are the best practices in terms of how you keeping the Terraform, like the Terraform files? I get it, the Terraform files are code, the actual code.
Yeah, yeah,
So, for instance, at FNB, there are multiple services that are working and are being deployed continuously every day.
yeah.
Where do you put your Terraform files? Are they in a separate repository where every service under FNB is going to have its Terraform files put maybe in a folder in a repository somewhere? Or do you bundle all of that Terraform code inside of the same repo as that specific service?
So that's the whole point of having, agile. You don't want to have one big thing whereby if it fails, everyone is going to get fired, because
Okay.
you've broken everything. So everything is broken down into smaller components, even an
Mm.
application, because back in the days, people used to write like one big application that takes time to even start up. Now we're using microservices. So the idea around microservices and your Terraform scripts and your CI/CD is that you trying to break things into smaller components and manageable components, whereby if something bad happens, we're only affecting a certain part of the service, not the whole entire service. Like for example, if you look at like an app, like let's use the F&B app, right? Whereby you have multiple things inside. It's not only F&B, even Capitec. You might find that actually, not that you might find, actually, you are actually, as you clicking certain buttons on that app, you are actually jumping in between different departments, because each department would be responsible for a certain feature on the app, right? So they would have their own sort of code, they would have their own thing, but it's not not everything is like bundled together so that when it breaks, everything just breaks. You basically separate it to, it's just that when you get inside, when you start to get exposed, that's when you realize that it's more like within your F&B, or you within your ABSA. As much as you are working for ABSA, but you might find that you are working within, let's say, central finance, or maybe core banking, whereby they deal with ATMs, but this side they deal with, let's say, HR stuff. But on the app, it looks like it's one thing, but it's not. It's different components and different departments in the background. So yeah, guys, I don't know.
Last
If you
question.
guys
Last
have any
question.
question. Yeah, sure.
Um, what project size would you say that DevOps should be implemented at? Like, can I start a startup now and get on with all the agile stuff and configuring CI/CD? Like, is
Yeah.
there a certain level where I need to now consider coming in with DevOps?
No, so remember what I said. So DevOps is not really a role, or sort of, it's just a way of doing things. Meaning that you as a developer, you can like implement DevOps practices like on your own. Right. So you can, from the very beginning, you like, look, I don't want to every time, for me, every time I have to write the code, I have to run it locally and all of that. You basically be like, okay, now I'm working on this project, and we are maybe less is the two of us, and we don't want to be saying, okay, I'm working on my changes, and then someone else is working on their changes, and then when it's demoing time to like, and we have to demo to a client, one of us needs to send their code over for us to measure it and all of that. You basically want maybe to have that sort of automation in place, so that things are sort of smooth and sailing. You can already have it, so it's from beginner to advanced. So that's why at the moment, there's a very much big buzz around DevOps. Everyone is like DevOps, DevOps. It's basically companies trying to realizing that actually we can save a lot of money by implementing DevOps practices, because then we are getting rid of us having a lot of teams doing having separate responsibilities, instead of us not, and we don't know what's actually happening. So with DevOps, we try to centralize everything and automate it, and also add visibility on what's happening in the background. So that's why a lot of companies now are investing a lot of money within DevOps, to say we want to do things in an automated way. They just companies are just trying to get to that point whereby they basically automate things rather than having a lot of human errors. Because remember, for a company, if it goes down, if services go down for something like 5 minutes, they might have lost quite a lot of money. So you don't want that. So that's why things such as Kubernetes are introduced in your cloud to say, if this thing goes down, this one still continues. So it's from a user point of view, nothing is affected. From a DevOps side of things, there's no sleep for you because you need to fix what's breaking. But the user experience and the customer experience is not affected.
Understood, sir. Understood. Do we have any more questions? Going once, going twice. I think we are safe to say we don't have any more questions. Nkululeko, thank you very much for the wealth of knowledge that you've with today. I'm actually very intrigued. I thought I knew a little bit about DevOps, but today, wow, there's a lot.
No, there's quite a lot. To be honest with you, even myself, I've been in the field, but you get like amazed at every time. Like there's a new tool that someone has or some team has introduced that you can use. So yeah, I know it's a pretty interesting path, really. I think you guys would enjoy it, really, man. We should give it a try.
Yes, we actually are trying to get started in that whole realm. So we have like a GitHub organization for our student society where we would all contribute in terms of code. And in that,
Nice.
we are also trying to establish a DevOps section where people would be taking care of everything a DevOps engineer would need to look at. So
Nice. No.
in that
Proper stuff,
space, we
guys.
would love to have you as our mentor, by the way, if you are available. Just to give
Absolutely,
us
anytime, guys. Yeah, no, absolutely. Anytime you guys want assistance or maybe a guide on how to do things, what you can use, how. I think I can learn quite a lot of things as well from you guys as well, So yeah, anytime, guys, really.
learn a lot of stuff as a senior from us who haven't even touched the field. Interesting.
Absolutely.
Okay.
So think of it this way. Your questions, you might ask questions that are actually, you might say, for example, you ask a question to like, why do you want to automate this when you can do this? Just a question can bring about like, a wealth of knowledge. So yeah.
Okay. So since we have established that we're going to have you as a mentor, can we please get your email so we can connect with you on LinkedIn? I tried to, and it said I need to send you an email first. I don't know if anyone else tried here, but yes, if you don't mind, sir. Do we still have you online?
Oh crap. I was muted, sorry. Now I was saying, I can see that I can't type over here. I will share it with Sarah, and then Sarah can share with
Oh,
with you guys.
okay.
Yeah, no.
Thank you.
Cool.
Well then, in that case, I think that brings us to the end of our meeting.
Cool. Thank you,
Thank
guys.
you very much.
Cool.
Thank you very much.
Cheers and talk soon, eh?
Cool. Definitely
Right.
getting in contact with you.
All right, cool. Cheers, guys. Bye.
Cheers. Bye. Hello guys, welcome to my YouTube channel.